I'm going to tell you about the view of Phoenix from the MRO spacecraft and the HiRISE telescope on MRO. And I'm going to talk about pieces of just two images. The first, if I could have the first slide, is the same image that Barry showed yesterday morning, only in our exuberance over seeing the parachute, we just zoomed in on the parachute. And then later, we zoomed out and were astonished to see the setting of this crater, informally called Heimdall crater, behind Phoenix as it descends on its parachute. So that's what's shown here, and it looks like Phoenix is dropping right down into the steep rocky slope of this crater. It isn't really. It's actually about 20 kilometers in front of this crater. It just happened to be right in the line of sight between MRO and this crater. There was Phoenix. So it's an optical illusion that's hard to understand because we're looking through a very large focal length telescope. And Phoenix, this really gives you an idea of how small Phoenix is in relation to Mars and this one 10-kilometer diameter crater. We've also done some improved processing of the parachute image, and we can see the gap in the disc gap band parachute. If you probably can't see it here on the TV screen, but on the web that will be shown. And there's some interesting dynamics of the parachute here. This opened about 20, we took this picture about 20 seconds after the parachute first opened. So then we took some images of Phoenix on the ground, and thanks to Brian and others, their work in locating it, we were able to hit Phoenix on the ground in our first two tries. The first one was 11 hours after EDL, and the next one was 22 hours. That image just came in last night, and Eric Eliason and others at our operations center in the wee hours of the morning here were processing that image and have it ready in time for us here today. So if I go to the next slide, we'll show you what Phoenix and other hardware, associated hardware, looks like on the ground. Well, here's a little video first, right? Here's the MRO spacecraft flying over with a simulated field of view of the HiRISE camera. Zoom in on the surface as shown here, and there is the image in color. In our second image, the knowledge of the location was so accurate that we could get it in our narrow color swath in the center. And there are three pieces of hardware that we should be looking for: the lander itself, the parachute attached to the back shell, and the heat shield, or its impact mark. And we see three things in this image which correspond to exactly, if I could have the next slide, I think there are some labels on this image. That's exactly what we see here. Well, we'll just zoom in here. At the bottom of that image is the parachute attached to the back shell. This is rotated so that north is down. So that's the back shell at the bottom and the bright parachute at top. And in the full-res image, you can actually see the stripes on the parachute here. You can see a hint of the strings connecting the two. And there's a dark area, which is where the dust was disturbed as this thing came to rest on the surface. On the next view, we'll take a look at the heat shield, I believe. And we believe there's two dark spots here. The one on the lower left, we believe, is the heat shield itself, or the marking made by the heat shield, and the one on the right is a bounce mark, or it could be the other way around. We're not sure exactly, but it's the marks made by the heat shield, and it bounced. This thing was dropped and just free-falled when it was released from the parachute. And the next slide shows the lander itself. There it is in color. It stands out remarkably well against dark red Mars. You see the two solar rays perfectly. We took this image to make sure, in case we were needed to verify that the solar rays were open. That wasn't the case. But you see those very well. And the bright spot in the middle is some specular reflections on parts of the lander, so it appears off-centered compared to the solar rays. So we're thrilled with these images. And now for a view from the ground, here's Peter.
Good morning. We're so pleased last night to be able to get some more images around our landing site. And if I can show the first graphic, we're looking now to the south, and this will be the first of a series of mosaics that will take us all the way around the 360 degrees surrounding the lander. But first we're looking to the south. And as we look into the terrain, we see the sparsely rocky surface, and we see the mounds and the troughs that represent the polar terrain on Mars. And we see a nice rock up close that has a very interesting shape, and we can zoom into the distance, and as we look straight south, just as Alfred has shown in his picture from the orbiter, we see the back shell and the parachute. Because there's so few pixels involved here, and that back shell parachute combination is, I think, 300 meters away, and so we don't get a lot of detail there. We just see a bright area. So we'll take a higher resolution picture later on and see if we can distinguish between the parachute and the back shell. Also in that image, if you look towards the horizon, you will see there's some low hills. Those are about 9 miles away, and they're just a little rise in the terrain that marks the valley that we've landed in. So about 9 miles away, and we can see it fairly clearly. That means there's not too much dust in the atmosphere. It's a very clear day on Mars. Our next image is even more exciting because this is where we're going to be doing our science for the next 3 months. This is our digging area where the robotic arm is able to reach and actually interact with the soil. Now, looking through the camera in this animation, and now we overlay the actual pictures of the digging area. And these pictures show that there's only a few rocks in the digging area, which is great news to me because the arm is not built really to handle a very rocky terrain. So we have lots of areas that we can dig in. You'll notice some of the rocks look like they've actually been shifted and moved a little bit. This must be because of the thrusters as we came down. They exert quite a force, and so they're certainly able to move some of the rocks. All of this is prime digging area that you're seeing here. You see some little streaks that probably came from the thrusters as we came down to the surface. And now look at this shift in the shadow of our camera. That's a self-portrait. Now those two masked pictures don't line up because the mosaic is taken over a period of time and the sun is moving in the sky. So the shadows have shifted between the taking of the upper picture and the lower picture, and that's why it doesn't line up. But this is a place we're going to get to know very well over the next 3 months. We are fairly sure, both from Alfred's pictures and from some preliminary elevation maps we've made, that we'll be able to get into one of the troughs between the polygons, and that has the science team quite excited to be able to look at the difference between the underlying surface and ice in the trough area and then in the middle of one of the polygons that we've seen.